Hello and welcome back to our tutorial about building the sample mash device. In part 2 we built a groove object, a waveform and a buffer, and we configured them to be able to talk to each other. In this session we're going to be building a random number generator to glitch the audio end position of the sample in the buffer. So let's get started. We can see here we're back in live. And we've actually got a few extra controls I've made to save a bit of time. So let's hit the edit button and have a look inside our patch. And let's leave presentation mode and go back to building mode. So this is exactly the same as when we left it in part 2. However, I have copied over the normal live.txt button and the message attached to it, and then simply edited the text inside each copy. So that was in the inspector, and this allows us to configure a different display of text on the button itself inside the presentation mode. If we go down to the bottom here, we can see we can simply change the text off label. So then I changed the value inside the message box, which is fired through to the speed box and eventually to the actual groove object. This section controls the playback speed of our groove. So we know that using an integer 1 plays the groove forward at normal speed, an integer -1 plays the groove backwards at normal speed, 2 will be forwards double time, 4 quadruple time, etc. So I made a few extra controls here that were all based across what we saw in part 2 to be able to control the playback speed of the groove object. I've also made another object down here, a live.txt button, and this is connected to another message object with the integer 0. And you see this one is going directly into the left input of the groove. It's not going via the number box and the sig. So if we select the groove object and have a look inside the help, we can see that in part 2 we learned that we could use different integers to control the playback speed of the buffer. So 1, -1, 2, 4, etc. And we can also see if we send in the value 0 directly into the left-hand side of the groove object, we actually start playback from 0 milliseconds. So this really resets the groove object back to ensure playback happens at the beginning of the sample. So let's close down the help for groove. So I did these in the background just to save a bit of time, but you're free to copy and paste as many different buttons as you like and create presets to control the playback speed for your groove object. You could choose different values and different labels, for example, in your patch. Okay, let's make a random number generator. So to do this, we probably want to make a bit of space within our patch. Let's close down the inspector for screen real estate. Let's lasso the majority of our patch and pull it downwards to create a bit of empty space that we can patch into. I'm going to stick the random number generator stuff round about here. It needs to sit between the info and the actual waveform object. So let's make a brand new object, N for new. It's called drunk. Drunk is the center of the random number algorithm. And we can see it outputs numbers within a step range. Let's right click on drunk, have a look in the help. Let's click on the toggle button above the metro and we'll see a little example. And we can see here we are outputting a bang into the drunk object and it's producing a number between 0 and 128, but each value is going to be within 5 of the previous value. The output of the random number generator is always going to be stepping within 5 integers from its previous value. And we're using a metro here to create the stream of numbers. The metro is outputting a bang every 100 milliseconds. Let's close down the help for the drunk patch. So the first inlet requires the trigger message. It's a bang message coming into the first inlet, will output part of our random number generator. Let's make a bang to trigger the drunk object. Let's press B for bang. Let's connect the output of the bang into the inlet of the drunk object. And let's make a metro, N for new, and type in metro. And we can see this outputs a bang message at regular intervals. Let's visit the help for the metro object. And we can see here, we can set a time in milliseconds into the right-hand inlet, the second inlet of the metro. So we could specify the frequency the metro will output a bang. So we'll create a little box like this and we'll allow the user to specify time in milliseconds. So for example, if the loop is 120 beats a minute, if they put 500 milliseconds in, they'll be outputting a bang at a quarter note value. So the end of the sample will be glitched every quarter note. There's more fancy things we could do. For example, we could configure the metro object to operate at different subdivisions of the BPM pulled in from live. However, that's a little bit beyond the scope of this tutorial. Let's shut down the metro help. And we'll connect the output of the metro object into the inlet of the bang. We need to provide our user a control to specify the millisecond frequency for the metro. So let's copy and paste the start millisecond live number box we created in part 2. And let's move that up to the top of the patch and connect it into the right-hand inlet of the metro. As usual, it's probably good practice to double check our parameters in the inspector for any objects that go into the graphical user interface. So let's make sure we have our new live.num box selected. Let's visit the inspector and we'll scroll down a little bit. In the parameters section, we want to be able to successfully configure our names. We saw quite a few examples of this in part 2. So let's change the scripting name to MS. Let's make sure link to scripting name is on. We can see the scripting name value has been pulled down to long name, and let's simply just then double click on short name and make sure it's the same. Now we can see here the range is going from 0 up to a very big number. We probably don't really need this so big. So let's set this to something a little bit more sensible, 0 to 1,000. Let's quickly add in a comment so we can actually label this for the user. The quickest way to do this is to literally copy an existing one. And let's just change the contents of the comment so we can actually label up the control for our user. Let's visit presentation mode, and then we'll just move over our new elements into a suitable position inside our patch. And again, you're free to configure these however you like. Let's visit patching mode again. So we can see now we've got a frequency speed that we can trigger our metronome. However, we do need to be able to provide a control to switch on the metronome for the user. Let's make a brand new object, and let's press N for new. Live.toggle. This is a message which switches between off and on. It transmits a 0 in the off state or a 1 on the on state. Let's configure the output of the live.toggle into the first inlet of the metronome, and let's select our live.toggle object, and in the inspector configure its name and properties. Let's call the name for this metro on. And again, copy and paste the value, switch on link to scripting name, paste it into short name. Let's add the live.toggle to the presentation by right-clicking and adding to presentation mode. And quickly visit presentation mode and set this somewhere suitably in the GUI. You can also make the toggle a bit bigger by dragging from the bottom right-hand corner, make it a bit easier for the user to be able to activate the algorithm. Let's come back to building mode. So we can see here we've now got a simple way to switch on and off our random number generator, but we need to configure our step size. So the second inlet in the drunk object sets the range size, which is the maximum duration our drunk object can take. So this needs to be defined by the maximum duration of the sample. So let's take the output of the flow number box we created in part 1 and simply patch that in to the second inlet inside our drunk object. Now the maximum number the random number generator will be able to create will be the maximum value in milliseconds of the length of the sample. Our next little section is to configure up the step range, and we want to be able to give the user some options to be able to configure this, so they could maybe specify short jumps or big jumps. So let's copy down our live.num box we created earlier for our metro milliseconds trigger. And let's move that down and wire that up to the third input of our drunk object. Once again, we want to configure this in the inspector to make sure our properties make sense. So we could call this in our scripting name steps. Make sure link for scripting name is active and just copy and paste down the long name to the short name. So you can set your maximum range for your steps parameter to whatever you like. Maybe 2000 might be useful. Let's give some labels for the user interface. Let's copy a comment. And we'll simply replace the text in the comment box. Let's call it drunken steps. Set this up however you like. It should be in presentation mode by default. Okay, let's visit presentation mode, finalize the last little bits of our GUI. And come back into patching mode. So it might also be kind of useful to be able to configure the metronome to have some default values that it uses when the patch is first switched on. So for example, we could select the metro, double click and add an argument to the end of its object name. So we're going to right arrow to the end, press space, type in 125. So the metro will default to outputting a bang message every 125 milliseconds. Let's select the live.number box we created to drive the second inlet of the metro. And if you come down in the inspector, you'll see in the parameter section, you can actually configure an initial value. You have to activate initial enable on the checkbox. This then allows you to specify a value that the number box will have when the patch is first loaded. So this is an alternative way to configure the metro speed. I'm just going to type in 125 into the initial value object. So max for live, you can actually initially set up a value, a default value for every parameter you have in your GUI. So you could, if you choose, go through all the different user interface elements and activate an initial value, which might be a little bit more friendly for the user when they first load your patch. It's fairly easy to expand this. We could put a couple of presets in here to provide some different values to fire in. So for example, we could simply copy two of our existing live.text boxes and our values here. And we can use these as little presets for the user. Let's type in 200 and maybe 1000. We'll connect these up into the live.number box for the drunken steps. And we'll change the text in the live.text button. So we could call this one little, and we could call this one loads. So you can see you could actually customize this further by adding more presets in here. You could add more presets over to the playback speed. You could actually provide several buffers, maybe a stereo object with a different loop on each channel. There's an infinite amount of things you can do inside Max for Live. It's kind of crazy. But for now, we've got a working patch. Let's save. Let's come to presentation mode, and we're quickly going to just adapt our little presets to a suitable part of the GUI. Save your patch, leave the patcher mode, back to live. And just load a new loop in, have some fun. So thanks for watching the tutorial about the sample mesh device. I'll be really interested to see what you do with these ideas. One of the great things about Max for Live is you could take existing work, existing ideas, and completely remix it in your own devices. And this gives you the possibility to explore concepts to enhance your own sonic personality and make your music stand out from the crowd. So if you feel like getting in touch, you can reach me via my website. I actually release quite a few free Max for Live devices. But send us some mail if you have any questions, ideas or queries. And you can reach me at this email address. So from Berlin, good luck and happy patching.